Okay, so starting with the first part of the focus questions here, which of the following is best defines forces? So we have one of these definition can be used to define force. The change in velocity over time, of course, it's not a definition of force. The resistance an object offers to change in motion, it's not considered as a force, but the best description here is a push or a pull that acts upon an object. Okay, going to next part, which is which of the following is non-contact force? Non-contact يعني it doesn't require a direct touch. Mainly we know we have two types of forces. Forces can be categorized as contact, or we have another type which is non-contact. So mainly the non-contact forces, or forces that don't require a direct touch, mainly there are three. We have gravitational force, or sometimes we call it as weight. We have electric force and the magnetic force. So these are the main non-contact forces. Other than that can be considered as contact. So going here, drag force is a contact. Normal force command is a contact. Tension force, it's a type of force exerted by a rope. So it's a contact. So the only one that is considered as non-contact is the weight or the gravitational force. Going to this question, the figure below shows two forces acting on a box. As we can see, we have two forces, 5 to the right, 3 to the left. What is the direction of acceleration? We're always knowing that acceleration is always to the direction of the greater force. So the greater force is to the right. So automatically acceleration is going to be to the right. Or we can consider that the acceleration is always to the direction of the net force. So here if we need to calculate a net force is 5 because it's positive minus 3 because these two forces in two opposite directions. So we're going to subtract to get the net force. Mainly it's going to be 2 newtons, whereas the direction is to the right, to the positive or to the right. That's why the direction of the acceleration is A, to the right. Here, what is the primary cause of acceleration? We know that to have acceleration, we have to have a net force. What I mean is, if the net force is 0, so in this case, we can consider that forces are balanced. So, and when forces are balanced, so acceleration is going to be equal to 0. So the main cause of acceleration is having a net force. Once we have a net force, let me just write this. So once we have net force, this means forces are not balanced. And since forces are not balanced, this means we automatically gonna have acceleration. So the correct description here is the net force acting on the object. So the cause of acceleration is here the net force acting on the object. We have to have a net force or unbalanced forces, so automatically we're gonna have acceleration. Going to question 5 here. Acceleration of the object is, based on Newton's second law, we know that net force is considered as the product of mass times acceleration. We can use this formula either to calculate force, mass, or acceleration by using this way. We know here this is the net force is equal mass acceleration. M is the mass, A is the acceleration, net force as the total force. Measuring unit of force is always Newton. Measuring unit of mass is kilogram. Measuring unit of acceleration is meter per second squared. So, going to the question, acceleration is option A, directly proportional to the mass. So, based on the equation here, acceleration is not directly proportional, it's inversely proportional. So this is wrong, which means when mass increases, acceleration decreases. It makes sense. Okay, going to option B, directly proportional to the net force. So going to this point here, acceleration and the net force, are they directly proportional? Yes, definitely correct. They are directly proportional, which means when we have more force, this means more acceleration will be caused. Yani, for example, if the net force is 4 and Newton, we have another case, net force is 20 Newton. So which one will cause more acceleration? Definitely more force. So that's why more force means more acceleration. So they are directly proportional to each other. So the correct option is B. Going to the next part here, the graph. This graph shows relation between force and acceleration. And we said whenever we have graph, automatically the first thing we think of as the slope. So if we need to calculate the slope here, the slope shows change of y over change of x, which means y2 minus y1, x2 minus x1. Now, y is representing force, as we can see here. So y is representing force, while x represents acceleration. So going to main formula, which is FMA, F over, let me change the color here. If we're going to divide force over mass, it gives, force over acceleration, it gives mass. So mainly here, the slope represents mass. So we can get information about mass by using this slope. And we know whenever the slope is steeper, this means greater mass. So the greatest mass goes for A. A has the greatest mass and D has the lowest mass. So because it is less steeper. Now, going to the point that talks here, we have 3 options. So which one of these options correct? Acceleration is directly proportional. We just answered this question, that acceleration directly proportional to the applied force. This is correct. Going to this, mass A is smaller than B, which is smaller than C. That is smaller than D. This is not correct. So mass A is greater than B, and B is greater than C. C is greater than D. This is correct. So the correct option is D, which is I and triple I. Here, the problem-solving question is the easiest ever because using the equation in a straightforward way to get the answer. Here, we're always trying to find the key words to help us to understand and to know which formula can be used. A box is, and its content have, this is the mass. So just underline what given we have to help us also to identify the given. So this is the mass. A horizontal force of 15 Newton is applied to push the box at, look, this is the key word, which is a constant speed. Before even we think of reading the question, just once you see this word, constant speed, write a note here. Since the speed is constant, this means acceleration is 0. This means the net force is 0. This will save time. This will save you time while solving the question. So we have, this is the mass, this is the force, the applied force, and what is the weight of the box. So we know that weight or the gravitational force can be calculated by using the formula m times g. And of course, you don't need to memorize the formula. We're gonna have the formula. The formula will be provided. So the mass here is given as 5g, either to be written as 9.81 or 10. Both are correct. So 10, it's gonna be equal to 50, and you don't forget the measuring unit, which is Newton, because what are you calculating here is the weight, which is the gravitational force. So 50 Newton. Going to the next part that talks about what is the net force on the box, and explain your answer. We already know the answer before even reading the question. Before, this word gave us an indication that acceleration is 0, so net force is 0. So you don't need to think. The net force is 0. It's written here, explain your answer. So you need to explain. The explanation will be, since speed is constant, since the speed is constant, or velocity is constant, it's written here, speed is constant. Since we have a constant speed, which means acceleration is 0, which means net force is gonna be 0 as well. Calculate the friction force due to the rough surface. So we need to find friction force. Now, mainly friction force can be calculated by two ways, two formulas. Either to use a formula which is mu times normal force, or we can use the formula of the net force, that the net force is equal to applied force minus the friction force. To decide which formula to be used, we have to think, do we have mu, which is the coefficient? No, we don't have any information about coefficient, so we're not going to use this formula. The formula will be used as this, which is the net force is equal to applied minus friction force. So let's apply. We know net force is 0, is equal to, what is the applied force? It's written here. The applied force is 15, and it's positive, so 15 minus friction force is x. Using automatically the calculator, we're gonna get, or by rearranging the formula, we're gonna have negative 15 is equal to negative x. Negative will be cancelled with negative, so x is 15 Newton. This is the friction force. Here, going to this question, let me just erase this part to be able to solve. Okay. Two men try to move 100-kilogram box on a frictionless surface. One man pushes, here it's not clear as well. One man pushes to the right with 150. The other man pushes to the left with 200. So if we just to help us to understand the situation, we can just draw a free body diagram. So we have two forces, one to the right, which is 150. The other one is to the left, is 200 Newton. We try to be I'm trying to be accurate by drawing 200 is larger than 150. Okay, what is the net force? This is the easiest question, because since we have these two forces in two opposite directions, so we're going to subtract 200 minus 150. It gives 50 newtons. But where is the direction? Which one is greater, the positive or the negative? Obviously the negative, so it's gonna be negative 50 newtons, or you can write the answer as 50 newtons to the left. Both ways are correct. Find the acceleration by using the formula of here Newton's second law, net force m times a. So acceleration will be the net force over mass. Our net force is negative 50 of a mass, which is 100. It gives, of course, negative, because acceleration is always have with the same sign as the net force. So it's gonna be equal to 0.50. You don't forget the measuring unit, which is meter per second squared. Now, calculate the acceleration if the friction force becomes 3. So now we're gonna have an additional force. So mainly the net force was negative 50 Newton, but here 3 more will be added, but it has a negative sign, so the total will be negative 47 Newton. Then to find the acceleration using same formula, which is net force of a mass, so negative 47 over the mass will not be changed, so 0.47 meter per second squared, but don't forget the negative sign. So these are the main points here. Finally, the last question that talks about remain in equilibrium, or whether the object will accelerate, how to decide based on the forces. Here, if the forces are balanced, so if the net force is 0, so if the forces are balanced, this means we have 0 acceleration, so it remains equilibrium. We call this case as equilibrium. But if the net force is not equal to 0, so forces are not balanced, automatically we are going to have acceleration, so it's not an equilibrium. Going to this case, obviously the forces here, the total force at the upward is 20 Newton, and here we have 10 Newtons, so it's not balanced, it's not equilibrium, so we're gonna have acceleration. Here, these two forces are equal, so they cancel each other out, so the only force is 10 to the up, so also forces here is not equal to 0, not balanced, we're gonna have acceleration. In case 3 here, The net of the downward forces is 20, while the upward force is 20, so they cancel each other out. So we have this scenario, which is the net force is 0, forces are balanced, 0 acceleration, and remain in equilibrium. For the part 1 is done.